Hello once again, and welcome to Knowing the Examiner's Mind Senior Secondary Physics lesson. In the previous lesson, we looked at the vernier caliper with its various parts and their functions. We also looked at an example on how to read the instrument. In this lesson, we are going to look at the micrometer screw gauge. We will look at the precautions that needs to be taken before using this instrument. We'll look at the functions of the various parts of this instrument and how to read it. The micrometer screw gauge is yet another great marvel of precision measurements. And unlike the vernier caliper, it measures thicknesses and diameters of very small objects with even greater accuracy. But before you use this instrument, it is very important to take some precautions. The first precaution borders on cleanliness. Make sure that both the object being measured and the measuring surfaces of the instrument are clean and free from any dust particles. Note that even small particles can affect the accuracy of the measurement. Therefore, wipe the faces of the anvil and the spindle. Emphasis here is being made on wiping the faces of the anvil and the spindle, not just wiping the anvil and the spindle, but their faces. Secondly, you have to zero the instrument. Check that the micrometer reads 0 when the spindle and the anvil are in contact without any object between them. If you are getting a reading other than a 0 after closing up the two parts, please take note of that reading. You will subtract it or add it to the final reading that you get on the instrument. That means you have corrected the 0 error. All right, let us look at the main features of this instrument and their functions. The diagram here is a typical micrometer screw gauge. Firstly, we have the frame. The frame is a C-shaped body that holds the entire device together. Then we have the anvil, which is a fixed part of the instrument that is attached to the frame. It supports the object that is being measured. From the anvil, we have the spindle. The spindle is a movable part that presses against the object. It moves towards and away from the anvil as the thimble is being rotated. Next is the thimble. This part is what you rotate in order to move the spindle. It has a circular scale on it, which you read in conjunction with the main scale that is found on the sleeve. Next is the sleeve. The sleeve is the part that remains stationary and has a linear scale on it, which shows the measurements in millimeters. Next, we have the ratchet. This part is used to apply a consistent force when tightening the spindle against the object. It ensures that an unnecessary force does not get exerted on the instrument, otherwise this might damage the instrument, knowing very well how delicate our instrument is. And finally, we have the lock nut. This part is used to lock the spindle in place once the object is positioned correctly between the anvil and the spindle, ensuring that the measurement does not change. Okay, how can you then get readings from this instrument? Let's look at the following rules that will help us to understand reading our micrometer screw gauge. Firstly, obtain the last reading that appears on the sleeve scale and you record it as S. So you simply look for the last reading appearing on this scale. That is your sleeve scale reading. Next, you obtain a reading on the thimble scale, which is in line with the sleeve line. And then you multiply this number by 0.01 millimeters or 0.001 centimeters so as to obtain your final thimble scale reading. Once you have these two readings, you simply add them up so as to get your total reading on the instrument. Let's look at an example that will clarify these simple rules. The diagram here shows part of the micrometer where the readings are taken from. The first rule tells us to get the last reading appearing on the sleeve scale, and from the diagram we can clearly see that the last reading appearing on the sleeve scale is this one. We can also see that between 0 and 5 on our sleeve scale, we have 5 divisions. Let me get my pointer. All right, so between 0 and 5, we have 5 small divisions, implying that each small division is a 1 millimeter. We also have other small divisions at the bottom. These are 0.5s, and therefore the counting on the sleeve is done as follows. We have 0, 0.5, 1, 1.5, 2, 2.5, and so on and so forth. And therefore our last reading appearing on the sleeve is this one, which is a 7.5. So that is a 7.5 millimeters. Next, we go to our thimble scale. This is our thimble scale. How do we get a reading from the thimble scale? According to the second rule, we are saying we obtain a reading which is in line with the sleeve line. Then we'll multiply this number by 0.01 millimeters or 0.001 centimeters, but we can clearly see that our instrument is in millimeters, therefore we'll multiply this number by 0.01 millimeters. So we can see from the instrument that this is a division that is in line with our center line on the sleeve. This is our center line on the sleeve, and the division which is in line with it is this one shown by the arrow. Now, what number is represented by this division? We can also see that on the thimble, let's say between 10 and 15, we have 5 small divisions, implying that each division is a 1. So counting from 10, we have 11, 12, 13, 14. Therefore, our reading there is a 14, which is being multiplied here by 0.01, giving us 0.14 millimeters. And finally, to get our reading, total reading on the instrument, we simply add the two readings, sleeve reading plus thimble reading. That is 7.5 millimeters plus 0.14 millimeters, giving us a total reading of 7.64 millimeters. And there you have it. With a bit of practice and attention to detail, you should be able to calculate any problem related to these instruments in no time. So grab yourself a pen and paper, roll up your sleeves, look for as many questions as you can, and keep practicing. Don't forget that you can also check out our books, where you will find a number of solved exam past paper questions and other questions which you can practice on. You can equally find similar examples and past paper questions in our mobile app, that is Examiner's Mind, which you can download from Google Play Store and share your solutions with us in the chat feature of the app. Until then, keep learning.